Welcome to another episode of the Manufacturing Executive Podcast. I'm Joe Sullivan, your host and a co-founder of the industrial marketing agency Gorilla 76. If you ask my 4-year-old son Jack about robots, he'll go running for his Optimus Prime figure or one of the other Transformers that are scattered across my house by the end of every day. When I hear the word robot, I by default think of big yellow robotic arms on an assembly line moving 100 miles an hour. My guest today, however, is an expert in a different part of the industrial robot, and that's the eyes. So let me take a moment to introduce him. Jonathan Berte is the mastermind and driving force behind RoboVision, the collaborative platform for those looking to lead the artificial intelligence or AI revolution. With a background as an applied physics engineer specialized in image processing, Jonathan built up a strong reputation building custom machine vision and robotic solutions in the first years of RoboVision's existence. The RoboVision AI software is what it is today in large part due to Jonathan building machine vision applications the hard way. Jonathan now passionately leads RoboVision to new heights every day. Jonathan, welcome to the show.
Thank you, Joe. Well, glad to be here.
Yeah, it's great to have you. This is such an interesting topic, and I talk to a lot of people who touch robotics and automation from a variety of perspectives, but you're kind of in this corner related to vision, and you got some deep expertise there. And I'm very curious to learn from you and sort of expand my own knowledge as you talk about your expertise.
Okay.
So, I guess like I said, Jonathan, to kick it off here, I know you're in this world of vision, the vision component of AI. And I'm just curious if you could start by telling our audience a little bit about your personal journey that led you into that niche and then inspired you to found RoboVision.
Well, that's a good question, Joe. It all started about 25 years ago when I started experimenting with cameras, and when I realized that this migration from analog cameras to digital cameras had also some a great potential. And I started basically dreaming about the potential when I was at the University of Zurich, Switzerland, programming a bot that could look behind the back of a croupier in a casino. So just to follow the game. And that's where I realized that not only these gimmicky applications would be cool, but also image processing and everything related to getting value from image streams, cameras, also in production conditions, would at some point in time be very disruptive. And I believe that early on. I started slowly as a consultant in the automotive market. It was really the careful first steps. We all know that the industrial space is very conservative, very robustness driven, typical component lifetimes of 5 to 7 years. So it was not an easy game in the beginning, especially because of PLCs, the standard S7 Siemens, Allen Bradley, the usual suspects, Omron being there. And this camera ecosystem was kind of a new kid on the block, but also a difficult new kid on the block because it was always the last component in an automation project, and and the most tricky one because you didn't have the production data yet. So that's where I felt the hard way what industrial conditions are back then. I really had a tough time those first years, 2004, 2005, in convincing people that there could be potential in this camera application, but there was simply not so much support. There were no large code bases out there. There was the term AI was really not used at the time, and it was seen as an extra component to a PLC. So every budget was like too much, and can't you reduce the budget somehow with less features? But in the end, it is it was a very challenging environment up until one point when things started to change, when digital cameras became more and more commoditized, and this whole AI revolution basically starting off in at Stanford, California, with Fei Fei Li, ImageNet, started to take off, and people started talking about deep learning. And that's when I deeply understood that the biggest disruption of all was not the camera itself, looking at production conditions and quality control at the production line. Now it was the algorithm creation. It was around 2010, 2011 when I basically started all over again and said, like, my business model is not scalable. I need to do something about the algorithm creation itself. And that's when I went back to university. A personal friend of mine that was professor at the time, a really cool machine learning lab that he headed. And at the time, some cool new guys were in this lab, Sander Dieleman and Aaron van der Oort, that are now like high profile DeepMind engineers. And they explained me that writing algorithmic software was coming to an end with the advent of deep learning. And that's why at around 2013, I really started off with RoboVision 2.0. We had designing a platform that made algorithm creation in the visual domain automatic. And that's the basis of the company, basically. Like you can create algorithms, whether it's quality control in the industry or COVID detection in healthcare. You can automate this process, which is the biggest disruption of all, Joe.
That's some really great background. It's such an interesting technological advancement. I'm just curious if you could talk a little bit about, some of the specifics of how the vision component of AI is advancing right now, and like what's possible now that may not have been possible even a few years ago.
Well, basically, if you look at the vision problem, you typically have this aspect of an object or something that you need to detect, or some aspects or artifacts that you need to detect from the object, and you have background. And in the past, like 10 to 15 years ago, you had to engineer all of this background subtraction, foreground extraction, feature detection, robustness. You had to do that all by yourself, meaning that it was really, you needed to handpick the features, you needed to know all about the possibilities. So typically a profile that had to write such an algorithm was already like a PhD degree. You needed like a PhD to be successful and to create a robust image processing algorithm 15 years ago. Now, this changed when researchers started to reverse engineer the visual pathway in the brain. And they realized that they started to realize some of the basic aspects of how a biological brain, a human brain, is processing visual information. And basically, that was the advent of deep learning, when actually the brain, people started to reverse engineering the brain. And this feature detection that was like a manual task 15 years ago became automated. And it's, of course, a big game changer, because those are the most expensive profiles in the industry, is the algorithm creators. So if you can just automate the smartest people, all of a sudden you can just do many more use cases and make many more algorithms. And that's the era we live in. It's the era of the commoditization of difficult algorithms, especially in the visual domain.
What are some of the most important applications of AI in the manufacturing process from your perspective, Jonathan? And also, I was curious if you could maybe share a real life example, whether it's from RoboVision, or if from a customer, or just something tangible to put some of this in context for listeners.
Like we all wear clothes, like trousers, anything. So these are processes that are going extremely fast. But if something goes wrong with the needles, and you have this textile being woven at very high speeds, if one needle breaks or something, and if it's not like noticed early enough, you have like literally hundreds and hundreds of meters wasted textile that really needs to go, down the drain. And this is where AI can be of uttermost, can really function well. It's like to detect these anomalies in woven textile, and as such, stop the production process if a needle breaks, so not to waste any more material.
That's a great example. So quality control, quality assurance would be sort of one place. And anywhere else that you'd touch on?
Object segmentation, like everything related to detecting an object, the pose of an object. For instance, a glue process, which we did for the Audi factory in Brussels. Like many parts of a car are being glued with high-tech glues. But then, of course, you need to check if the glue has been put well on the material. And this kind of processes can be automated with AI in a visual way, but also picking, like object picking. If you have like a conveyor belt where a lot of product needs to be packaged or need to be quality controlled before packaging, then you typically need to know the position and the exact pose so you can pick it up with the robot and put it in a box.
That's great. One common theme that seems to emerge from week to week in my conversations with manufacturing leaders who are coming from all different kinds of backgrounds in the industrial sector is this concept of the manufacturing labor shortage, or this problem, I should say. And when you and I talked a few weeks back in preparation for this discussion, you said something along the following lines. I'm probably going to butcher your quote, but this is how I wrote it down. You said something like, if you want to double revenue, finding the labor is the biggest barrier. And I'm just kind of curious to hear you talk a little bit about what you mean by that and how you see the role of AI alleviating that pain.
Well, many of the, for instance, quality control issues are very tedious tasks, and they need to be done literally 24 hours a day. So if at 4 p.m, you are a worker and you need to look at textile for hours in a row with big lamps shining in your face, it's just simply not going to work. So many of these people get tired, it's difficult to keep focused. So at some point you will just waste material because that's not what humans are supposed to do, like looking at textile hours in a row. So if you don't have these profiles, or if you cannot automate this process, then you will just have more material waste. So you will have revenue, you'll have more costs. That, and also these profiles, especially in very industrialized countries like Belgium and Holland, they're difficult to find. So you have this typical labor migration aspects, people coming from Eastern Europe in our region. It's just very difficult to keep production running with labor shortage, especially in pandemic times when you have all of these regulations keeping distance. So it's a whole challenge to keep the factory running at the heat of the pandemic.
And are you finding from talking to your own customers and other people in the manufacturing space that the problem around labor is that people just don't want to do those jobs?
Exactly. Yeah. Well, what you have is, I don't know if you have children, I have 3, but one of the funniest movies they like to watch is just like, it's decades old, even more than 100 years old, I suppose. It's Charlie Chaplin. And we all know this image of Charlie coming back from work and still having this kind of movement in his arms because he has been screwing all day the same screw. And our children just laugh with it and they say like, oh, that's just so funny. Was this like really happening, or is this just a movie? No, it was really happening. And still there are a lot of jobs that are just very pinpointing one task. And I respect all operators and all backgrounds, but there are plenty of other jobs to do than just screwing one screw. That's just not a very humane thing to do 40 hours a week.
Yeah, and I love your Charlie Chaplin example there. It's, because it is true, and everything that I'm hearing is that, the younger generation coming into manufacturing, that they just don't want to do these jobs. The baby boomers are exiting the workforce, the ones who were comfortable doing these jobs, maybe more than the younger generations, and so who's going to do them? And the reality is there's a big opportunity in robotics to fill jobs that people, frankly, just don't want to do, and as a result, manufacturers are kind of left, stumped with how do we fill the void. So makes sense.
Absolutely. And that, and also the aspect of more and more customization, like the industrial revolution has of course come up with mass production, but at this moment mass production alone is not enough. We all want customized products, and this customization is just hiring the manufacturing complexity, and you cannot just educate a worker with a variety of 400 different types of products that were just one unique type 20 years ago. So it's just much more easy to put these flows into robotic camera vision streams.
That's great. One takeaway I have here is I'm going to have to see if I can get my 4-year-old and 6-year-old watching some Charlie Chaplin instead of just Paw Patrol. So
Yeah.
we'll work on that. Jonathan, I've heard you talk a little bit about cloud versus edge technology as it relates to scaling your quality operations. And this is admittedly a knowledge gap for me. I don't know a whole lot about this, and differentiating between cloud and edge technology. They're kind of buzzwords to me. And I'm wondering if you can enlighten me and maybe some of our listeners who may be feeling the same thing about sort of where this fits into the discussion that we're having here today.
Well, it's a very good question. And some years ago, cloud was seemed contradictory to production management systems and quality control systems, because everybody was responding along the same lines. Like, what if your internet connection just breaks down? And of course, that can still be a possibility. But with 5G, with these low latency networks, high bandwidth, with not only a fiber connected to your company, but also other kind of second choice or backup systems. Cloud is really becoming of primordial importance in quality control, because of the fact that you can just easily scale up. You can just have the scaling operations run by your cloud provider. In contradiction, if you have like an edge application, if you want to have a double production or create a new production line, you literally need to go and buy components. You need to have this edge devices installed and calibrated. So the scalability is less with edge, but in some use cases, and we have industrial customers that work at air-gapped environment, also because of production secrecy reasons and so on. Then you, of course, need to resort to edge compute. And edge compute is basically an AI hardware device near to the production site that is just having a very small loop, image acquisition, inference of the AI model, an operational results that will lead to a PLC, like pushing out the product if it's below quality. So that is basically the reasoning between cloud versus edge. So cloud is your compute localized at a cloud provider, Azure, Microsoft, or Google Cloud, or Amazon Web Services, whereas your local edge is a device such as an NVIDIA Jetson, like a small GPU, which is very near to the production where it happens, in some cases even above the conveyor belt, looking at the product and giving a direct output to the PLC to steer some operation. So both have use cases. Cloud is more scalable. It's also easier to update, because basically it's just your cloud provider updating to new GPUs or something. So yeah, that's the game is very depending on the use case, Joe.
That's great. I appreciate you kind of giving me some more insight into that topic. Well, Jonathan, you and I sort of met via the Industry 4.0 group that is sort of taking root on Clubhouse right now. I keep talking about Clubhouse, I feel like, in every episode of this podcast, because it's just becoming, a really interesting place. And I think there's some pretty cool things happening in the manufacturing sector there. I thought I'd just kind of ask you, what are you seeing on that platform in terms of conversations that are happening around AI and robotics, and just kind of curious how that's sort of influencing you and the potential you see there.
I just love it because of the correct. You can really make a connection with some other AI entrepreneur or somebody responsible for production, and go into these conversations. It's a really good tool to learn about the world, how other people and other teams are solving problems in other continents, to sync and give each other advice. I think it's the next big thing in social media, but I'm biased because I'm kind of a bit addicted to Clubhouse right now.
I can understand how it would happen. It's I've participated in as an observer largely in that particular group, Industry 4.0, mostly just to sort of see what people are talking about and learn and enhance my understanding of some of these topics. And then I've been sort of running some of my own conversations more related to marketing and sales and in the manufacturing space. But it's pretty interesting. And there's a lot of smart people. I don't want to say I'm surprised that the manufacturing sector is there, but I am a little surprised at how much it's taking root. And so curious to see kind of where things go on that front.
Yeah, and also to form new relationship, to talk to potential partners. It's just so much more easy than a cold email, just to have a conversation, just talk informal and afterwards about a very specific project.
Something for sure to actually hearing someone's voice rather than just reading words on a screen, right?
Yes.
Great. Well, Jonathan, is there anything that I did not ask you today that you'd like to touch on while I've got you here?
I mean, we didn't really talk about the combination of robotics and AI, in the sense that what's next in this combination. I see that a lot is changing also in North America with Boston Dynamics and all of these new robotic frameworks, Berkeley based. So I do think that flexible manufacturing is really taking off if robots are much more easy to program. And if you combine deep learning with advanced robotics, I see a lot of difficult tasks like welding and molding and CNC manufacturing being replaced by smart robotics.
Yeah, it's such an interesting space to be watching right now. I had recently on one of these episodes, I had Ryan Lillibridge from Mission Design and Automation on here, and he was, he brought up the fact that robots have been around now for something like 60 years, which kind of, I almost had to ask him, like, did you say 60 or did you mean 20 or 30? Because you almost don't realize it, but some of the advancements that are happening right now are really kind of there's just so many cutting edge things. I mean, you've talked quite a bit here today about, where vision fits into that, but, from robots as a service to being able to, the advancement it's in cobots and, robots working alongside people in safe environments that are becoming more safe, whereas the robots were always traditionally caged. And, I think it's really interesting how fast things are changing.
Absolutely. And I'm really looking forward to this future where, robots are even becoming more smarter than they are today. So very passionate about technological advancements.
Great. Well, Jonathan, this is a really great conversation. I appreciate you doing this today.
You're welcome, Joe. It was really fun to do.
Great. And can you tell our audience about where they can get in touch with you and also where they can learn more about RoboVision?
Yeah, the best way to get in touch with me is via LinkedIn, just Jonathan Berte, and you will find my profile, or to follow the robovision.ai LinkedIn page. or just the website, robovision.ai, see what use cases we have, how easy it is to create new algorithms with our platform, and how we can solve your next challenge in manufacturing. So it was great talking on this platform. I'm really looking forward in bringing to you some lessons learned that we've learned in manufacturing halls here with AI robotics in Europe, and open the American market for advanced AI technology.
Great. Well, Jonathan, once again, really appreciate you doing this today. And as for the rest of you, I hope to catch you on the next episode of The Manufacturing Executive.